other. This is problem C. We will go over this very quickly. Okay. Number 1, if I look at this entire thing to be let us say a body, rigid body, there are 2 constraints over here and 1 constraint over here, which means if this were a rigid body, these constraints are enough for it to be constrained completely from movement, correct. Now apart from that, I need to have the internal system to be a rigid body, completely a rigid body, right. We will start from here. This is a triangle, this is a triangle, this is a triangle, this is a triangle, which means this entire set I am talking about is a rigid body. Okay. To this rigid body is connected another rigid body, one more rigid body here and one more rigid body here, but this does not form a triangle, which means it is possible for it to stretch out like this between 2 and 6 or 1 and 7 and such a body, if I put one more here, it would have been completely constrained to be a rigid body, or in other words, since I am breaking this, this has 1 degree of freedom, right. Apart from this 1 degree of freedom, if I look at external constraints, the external constraints are not enough to completely arrest this motion, and therefore this becomes a mechanism, it is not completely constrained. Okay. Now the question is, can I solve for the member forces? Okay. Now this is a question that is very difficult for me to answer now, because the system itself is a system that is not in static equilibrium, or in other words, it is a mechanism, and therefore I should not seek to solve for member forces directly. Okay. This is problem number E, am I right? What do I need to find out? The same thing, whether the system is completely constrained and whether it is possible to solve for all the unknown forces. If I do the same exercise, okay, for now I am just going to do a small change over here. If I remove this member 8 and this member 10, what do you notice? It is similar to the body that we had earlier, or in other words, it consists of non-overlapping triangles, right. This is one triangle, this is another triangle, this is another triangle, another triangle, another triangle, another triangle, which means it is a rigid body. It itself is a rigid body, even if I do not have 8 and 11. Are you with me? If I put this 8 and 11 in addition, will it still be a rigid body? The answer is yes, right. So it is a rigid body, this totally is a rigid body. There are 3 external constraints, which means that it is completely constrained, no problem, right. So it is a completely constrained body. If I have to now write down how many unknowns are there, how many equations can I generate, there are 3 constraints over here. But 15 member forces. Which amounts to 18 unknowns. How many equations can I generate? The answer is the same. I have 8 joints in total, which means I can generate 8 into 2, 16 equations. am sorry 8 into 2, 16 equations. 18, 16 there is a mismatch, 16 equations are not enough to solve for 18 unknowns, which means that it is not possible to determine the unknown forces using equations of equilibrium alone, and therefore, this is an indeterminate and constrained system. Okay. There are other notions of simple truss etc. I will not explore that. If you did not have this 8 and 11, you will have non overlapping triangles. Such trusses are called simple trusses.